Hi, my name is Jesse Astudillo. I'm here at Morrisville State College, and I'm in the BT program. I transferred from Trident Community College. This is my second year, and today we're going to talk about the 82700 R4 transmission power flow.
Good morrow, young scholars. My name is Michael Tomaskovic. I'm currently an automotive technician for Chrysler Corporation, and I am finishing up my fourth year here in the Bachelor of Technologies program. Today we are going to show you some power flow with our 700 R4 transmission.
Hi everyone, my name is Michael Nicoletti. I'm a senior here at Morrisville State College. I'm enrolled in the Automotive Technology program for Bachelor's of Technology. I'm expected to graduate in May of 2016, and today I'm going to talk to you about our 82700 R4 GM transmission, and we're going to do part 1 of 3, which is power flow. What we're about to see is our 700 R4 transmission already pre-assembled. What you're about to see shortly is our 700 R4 transmission already taken apart with all its internal components exposed, easy to see, and they're labeled, so it's easy for everyone to follow during a little power flow demonstration.
See, this transmission has been taken apart and is fully, as you can say, naked right now. So there's nothing in here that we're gonna talk about. This is just an empty shelf.
Three planetary gear sets are used in our transmission to achieve power flow, whether it be underdrive, overdrive, direct drive, or reverse. A planetary gear set is made up of three essential parts: the ring gear, located on the outside of the set, the planetary carrier, to which there are planetary pinion gears on and rotate around the ring, and the sun gear, which sits in the middle of the planetary carrier and drives the planets around the ring gear. In order for power to travel, you may only have one input, one stationary member, and one reactionary member. An example of this would be if you took your hand and held the ring gear. That would act as your stationary member while driving the sun gear, making that your input member, which then in turn rotates the planetary pinions and the carrier around the ring gear, creating your output.
Alright, so next up is that we're gonna show you what's inside the power flow, what actually makes the power flow go. So first things first is you gotta wear safety glasses at all times, make sure your eyes protected. You know, right here working on heavy machinery, anything could be flying out, so you want to protect your eyes. Okay, first thing that we have is our front drum, which contains the reverse clutches inside in there, and it also has a bearing inside of here. And this goes in front right here, inside the input shaft, like that. Let's take this out for now. Set this apart right here. Next up, from the front drum, we have the input housing, which contains the 3/4 clutches and a planetary set gears in there, as you can see. And this goes inside our shell, just like that. Next, we have our shell, which also contains another planetary sun gear right here. And our planetary gear. You want to take a little closer look? We'll put these back inside. Just like that. And we take this off. There's another sun gear in there. This is our low rear reverse clutch support. Next up, we have the rear planetary set, which comes out of the output shaft. And together is hooked up with the rear ring gear, which is this one. And if we put everything back together, it should look something like that in your transmission.
Alright, this is what your typical clutch pack looks like. Also, they all almost look like this. And they all consist of regular clutches. This is what one actually looks like. And you have your steels. This is what a steel looks like. The orders is always clutch, steel, clutch, steel, clutch, steel. It depends on what the type of transmissions and what gear it is. And every clutch pack has its reactionary plate.
Alright, we're going to take a look at the application chart for the 700 R4 transmission that we have selected for our project. On the left side of the chart, we see our range options: park, neutral, drive with the box around it, standing for overdrive, which means that this range will have first, second, third, and fourth gear. Drive with just the D, which symbolizes that there is no overdrive in this gear, as it only consists of first, second, and third. Low drive 2, which only consists of first and second gear. Low 1, which consists of only first gear. And reverse, which is reverse gear. We're going to focus in on the drive range with the overdrive function. As in all the other ranges, the gears have the same applied and holding elements. If we take a look at first gear, you will see that the forward clutch is applied, while the forward sprag clutch assembly is being held, as well as the low roller clutch. In the second gear, the 2/4 band is applied, the forward clutch is applied, and the forward sprag clutch assembly is being held. Third gear, the forward clutch is applied, while the forward sprag clutch assembly is being held, and the 3/4 clutch is applied. Fourth gear, the 2/4 band is applied, as well as the forward clutch and the 3/4 clutch. Throughout all the gears, the forward sprag clutch assembly is held due to the fact that it is splined to the case and therefore never moves.
Alright, so now what we're going to show you now is the gear ratios for first, second, third, fourth, and reverse. So, for example, this little retaining disc here is held constantly by the case. So this will always be stationary. So first gear is this little retaining disc in the sun gear, and the gear ratio is 3.06. So that's every 3 turns of the sun gear is 1 turn of this output shaft. So which I will demonstrate. Keep an eye on this label. Granted, my hand's a little small, so our turns weren't exact, but as you see, it's back where it was, and it was 3 turns of the sun gear for 1 turn of the output shaft. Okay, second gear's gear ratio is 1.63, so it's every just over 1.5 turns of the input shaft is 1 turn of the output shaft. So second gear, this ring is held constantly, and this planetary housing is also held at the same time. So I'll start spinning. See? Like you see, just over 1.5 turns, and the output shaft is back where it's supposed to be. Now for fourth gear, the ratio is 0.7 to 1, so it's just under, and that's where you, and also fourth gear is technically overdrive, and that's where you get the most fuel economy. So just under a turn of the input will be 1 turn of the output, which I will demonstrate. Again, granted, because my hands are a little small, my turns aren't exact, so it looks like it was more than a turn, but hindsight, where markers are, it was just under a turn. And now for reverse. Reverse is negative 2.29 to 1. The reason it's negative is because the whole planetary assembly spins backwards, which you shall see. As you can see, that was just over 2 turns for the input for 1 turn of the output. As I can see, it is very heavy.
Got it. Got him.